Okay. So in this today class, we will discuss about the basic of operational amplifier, and then we will discuss about the importance of op-amp, that why actually we will use op-amp in our daily life, and after that, when you use op-amp for our specific circuit, then we have to analyze the particular circuit, right? So in that case, some of the assumptions that we have to make regarding to solve the circuits, and that is actually op-amp golden rule. So many of people, they actually say this is the assumption of op-amp. Okay, so this is the things that I discussed before, but in today's class I will recap everything, and then in the next class I will move on the intermediate level circuit analysis for operational amplifiers, and then we will discuss about some basic op-amp circuits. These are nothing but inverting op-amp and non-inverting op-amp circuits. And after that, I will discuss about op-amp IC741 that actually we will use in our lab for conducting experiment. Okay. So these are the contents. Okay. So what is an operational amplifier, or what is op-amp? So an operational amplifier is an integrated circuit that can amplify mixed electric signals. An operational amplifier has two input pins and one output pin. So here you can see there are two input pins and one output pin. Its basic role is to amplify and output the voltage difference between the two input pins. So here its particular fundamental job is that you will provide two input over there. It will find out the difference of that particular different inputs, that particular two input, and then it will amplify it. Okay. So this is the fundamental job or responsibility for operational amplifier. And after that, here you have to provide the power supply. This is the positive power supply terminal. This is the negative power supply terminal. So you have to ensure the positive power supply and negative power supply equal. For example, here if you provide here plus 15 volt, definitely you have to provide here minus 15 volt. Okay. Otherwise, the output, it will not be amplified. Okay. So if I discuss about the general equation for that particular op-amp, so the output of that particular op-amp, it will be V0 is equal to A V1 minus V2. So this is the case. So it can be also, you can write V2 minus V1 if you want to say. So this is the general equation of output for operational amplifier. Okay. So this is the case. And now what an operational amplifier can do. So what is the importance of operational amplifier? These things we will discuss here. First of all, it enables the substantial amplification of an input signal. Okay. So you will provide a signal over there, and you will able to find out to amplify this particular weak signal, right? See, without the amplification, like you have a sensor, and the sensor is provide some output to you, and that output is the input to the microprocessor. MCU means microprocessor unit. Okay. So here one thing is that, so what is actually it does, that since the signal is very weak, it cannot process the weak signal. So you have to amplify that particular signal by using the op-amp, and here you can see the weak signal that is actually sending by the sensor, that is actually amplified by the op-amp and it becomes larger. So now microprocessor unit or computational unit, it can easily process the data. Okay, since the signal is larger and strong. Okay. So I have a question to you. Does that this sensor output here that you can see is become larger and stronger? Does it change?
No, sir.
No, because you are multiplying with the gain, and that's why the signal is actually amplified. But you didn't change anything fundamental characteristics of that particular signal. Okay. So this is the first thing that enables substantial amplification of an input signal, and second one is that enables any elimination of noise from an input signal. So, for example, when I am talking here, surrounding there are some noise, right? The AC noise, or maybe people can talk unnecessarily. So here we have to filter in that particular noise, otherwise that computational unit cannot process the data, process the signal. So therefore, op-amp also has been used as a filter. Okay, first of all, it can be used as an amplifier. It will amplify the weak signal to the large and strong signal, and also it can actually exclude the noise signal. Okay, and it will send the signal to the computational unit without complete noise. Okay, so it will be very easier for the computational unit to compute the data properly. Okay, so these are the two major importance or significant role of op-amp in our daily life. Okay. So what the golden rules are? Okay, there are two particular golden rules. First of all, actually I discussed this thing before, but here first of all I will discuss in very short here. Rule number one: the voltage plus and minus will equal to each other, right? For example, the voltage at plus will equal to the voltage at minus. That means that the voltage of that particular terminal will be equal to that particular terminal. Okay, so if you can find out the voltage of positive terminal or non-inverting terminal, you can easily find out the voltage of that inverting terminal. Okay, so this is the first one, and the second one is that no current can enter an op-amp. So in that particular terminal, non-inverting terminal and inverting terminal, no current can enter over there. So that means there will be no current. Okay, so the current will be flow from here to here. Okay, so this is the particular golden rules that, or the assumptions also we can use for the op-amp. So this particular golden rules, it will be very much important when you will analyze the circuit. Okay, without this assumption you cannot actually solve the op-amp related circuit here. So for understanding these things is very important. So now this is the basic of op-amp circuits. This is the inverting amplifier. An amplifier which produces a phase shift of 180 degrees between input and output is called inverting amplifier. The circuit that I have actually shown over there, I hope you can draw it because I already showed these things before. So first of all, the output that you will get over there, it is minus Rf over R1 into Vn. Okay, so here you can see that for that particular minus, the signal that it will provide to you, it will be shifted 180 degree, and therefore it is actually called the inverting amplifier. Because in the previous class, in the experiment when we have conducted, we found that it is really happened. Okay. Okay. So first of all, there the signal you can see, this is the positive. When the output you will get, this is the input signal. The output, it is actually inverted by 180 degrees. Right? So this is the actually phase shift of 100 degrees done as output. So that's the reason actually this is called as an inverting amplifier. So this is the circuit. Sometimes you have to, if anyone asks, if the examiner asks you to draw the inverting amplifier, then you must have to know how to draw this particular circuit, and you have to analyze these things. Okay. And the non-inverting signal is a similar thing as the inverting signal. The differences is that the non-inverting amplifier, it will produce the output as input. Right? It will not change, it will not shift the phase of the input signal. Okay. So here the non-inverting amplifier means that an amplifier which amplifies the input without producing any phase shift between input and output, that is called as inverting amplifier. You can see over there the equation of the output signal is that V0 is equal to 1 plus Rf over R1 into Vn. In the previous class, actually I showed you how to calculate and analyze this. Since this is the recap class, I am not actually writing these things again. Okay. So here you can see this is the input. So if you see the positive phase over there, the phase is not shifting. The phase is not shifting. So since the no phase shift happened over there, so this is the signal. We can say that is non-inverting signal. So this is the non-inverting amplifier since it is not invert the input. Okay. So these are the main basic operational amplifier circuits: inverting amplifier and non-inverting amplifier. And rest of the part that actually we discussed: voltage amplifier, voltage follower. Okay. Then 3 input adder or summing amplifier, and integrator, differentiator, subtractor, comparator. Those are the applications of op-amp, and these are the basic op-amp circuits. Okay. Those are also circuits, but those are the applications that we use in our daily life as our requirement. Okay. And this is the IC741. That is the most popular IC version of op-amp. It has 8 pin. First of all, that particular 2, 3, 4, 7, 8, 6. Those terminal we must not use in our lab. And offset null. Those things actually use to equalize the voltage, right? To make it 0 input voltage. If there is no input voltage, there will be no output voltage. So for ensuring this particular criteria, you have to use that offset null 1 and 5 terminal. But in that case, actually we will not use this pin in the previous lab that we conducted. But the first of all, you will provide the inverting input using that 2 pin, and number 3 pin is you will be used as a non-inverting input. You will see your output from pin number 6, and 4 and 7 it will be used to provide the power supply. Okay, positive and negative respectively. Okay, so these things actually mentioned is over there. See, pins 1 and 5 are offset null pins, and these are used to nullify the offset voltage. So what is offset voltage? We discussed these things when we discussed the parameters of op-amp in the previous class. And here pin 8 is a dummy pin, and there is no connection. Okay, it is made to this pin. So this is a dummy pin. No connection is made over there. So you do not need to connect anything here. Okay. So these are the basic pin diagram of IC741. That is an op-amp that we use a lot in our experiment that we conduct in our lab. Okay. So these are the things. This is the end of that particular tutorial class. I discussed everything basic that I discussed in the previous class. This is the recap class. So after that session, if you have any question, then let me know. Okay.